Okay, this is the second part of lesson 27, which is still on polar coordinates. So you're going to be asked on your test to switch from polar to rectangular or from rectangular to polar. So rectangular is an equation that just has x and y. And a polar equation is going to be an equation that has r and theta. Okay, so there are three different equations that you need in order to switch from rectangular to polar or polar to rectangular. So I know I wrote this a little bit funny in your notes, but you could have all three different equations. So these are the three that you need to know. So the first one is that x equals r times cosine theta. The second one, oops. The second one is that y is equal to r times sine of theta. And then the last one is that r is equal to the square root of x squared plus y squared. In other words, r squared is equal to x squared plus y squared. Okay, so for the first one, these first examples are in rectangular form, so they all have x's and y's, and we want to switch it so that everything is in terms of r and theta. So if you have x equals 4, we can replace x with r times cosine theta. So what we really have is that r times cosine of theta is equal to 4. So if you solve for r, which most of the polar equations will be solved for r, you will get r equals 4 over cosine theta. In other words, r equals 4 times secant theta. Okay, part B. So I have x squared plus y squared equals 36. So we're very lucky because we have x squared plus y squared, and remember that x squared plus y squared is equal to r squared. So in this equation, we have r squared is equal to 36. Now, if you think about polar coordinates, if you have r, like this means that r is equal to plus or minus 6. If you have r is equal to 6, should have done a smaller number, that means that you have a circle, right, with a radius of 6, so it's going all the way around here. So if you have r equals negative 6, well, it's really the same circle, because if r is equal to positive 6 or negative 6, right, it's really the same distance from the origin. It's just, remember when we had like negative 3 comma pi over 2? That's like saying go along the pi over 2 line, which would normally be this way, but instead we're going negative. So we're going to go 1, 2, 3, and it would actually be here. Okay, so having r equals negative 6 is really the same thing as r equals 6. So we're just going to say r equals 6 because it's a little bit redundant to have both. Okay, and then on this part C, we have x squared plus y squared. So we know that x squared plus y squared is equal to r squared. So I have r squared minus 7y equals 0. But I'm not done because I don't have everything in r and theta. So now I need to replace the y with r times sine of theta. So we have r squared minus 7r times sine of theta equals 0. And what we're actually going to do on this one is we're going to pull out the common factor, which is r. And if you think about setting each piece equals 0, if you had r equals 0, right, that's just going to be the pole, or the origin, as you might think of it, right? R equals 0 is just saying on your polar form, you just have that point right there. But this is not just the origin, right? Right, you can't, it's more than that. It actually ends up being like a hyperbola. Well, not a hyperbola. It ends up being an ellipse. If you think about your algebra 2, like x squared plus y squared equations are the ellipse equation. Okay, so it's not the origin. Okay, so what happens is it's going to be this equation, which is r equals 7 times sine of theta. And this is the one that we're looking for. Okay, so you actually, when we have something like that, if we can pull out the r equals 0, that's not what it is. It ends up being the r sine of theta. And you can try to graph it to see if you use like Grapher on your computer. So if you open up Grapher, all of you have that on your computer, and put in x raised to the 2 minus 7y plus y to the 2 equals 0. And you will see that it is an ellipse. And it ends up being this one. So you can check on your graphing calculator with polar coordinates. All right, so that's how we switch from polar to rectangular. So let's go from rectangular to polar. And this method is a little bit harder. So if I have r equals 10, r we know is the square root of x squared plus y squared equals 10. So what I would probably do is write it as in like the most familiar form possible. So if you square both sides, you'd have x squared plus y squared equals 100, which we can see as a circle. Okay, if we have r equals 12 cosecant theta, well, we know that if we divide by, kind of close to the form that we know, if we divide by cosecant theta, we get r times sine of theta equals 12. And r sine of theta is the same as y, right? So we get y equals 12. Okay, so the first one was a circle, part A. This one, y equals 12, ends up just being a horizontal line, right, through 12. All right, so the next one. So if I have r plus r cosine theta, r is the square root of x squared plus y squared. And then r cosine theta is just x. So we have the square root of x squared plus y squared equals, or the square root of x squared plus y squared plus x equals 4. And if you really wanted to write it in a different form, what you could do is you could subtract. I'm fine with leaving it this way. But if like Math Excel asks for another form, you could subtract over and then square both sides. So you'd get 16 minus 8x plus x squared equals x squared plus y squared. And then if you subtract the x squareds, it goes away. So you get y squared equals 16 minus 8x. So now when you see it in this form, you can really tell that it's going to be like a parabola on its side, if you remember from Algebra 2. So that's really kind of a nicer form, I guess. All right, so the next one. So if I have r minus 3 cosine theta equals 7 times sine theta, we know that if we have r sine of theta, we know that's y. And if we have r cosine of theta, it's x. And we're almost there here, but we're missing r's, right? So what we're going to do is we're going to multiply both sides of the equation by the same thing. We're going to multiply through by r. So we're going to have r times r minus 3 cosine theta equals r times 7 sine of theta. And when we do that, we get r squared minus 3r cosine of theta equals 7r sine of theta. So r squared we know is x squared plus y squared. And then we have 3 times r cosine theta. Well, that's going to be 3 times x equals 7 times y. Okay, and then we can leave it in this form. That's fine. Or you can move it around if you wanted to. But you should always be thinking about, like, what form is this in the end? Like, what shape will this make? So since you have an x squared and a y squared term, it's either going to be an ellipse, a circle, or a hyperbola. But since they're both the same, since I have 1 x squared plus 1 y squared, it actually ends up being a circle. So this is the form of a circle. So there are other things that you could do to get it like in standard form. So, you know, if you were in a pre-calc class that was longer than just the summer, I'm sure what I would have you do is I would have you rearrange and then have it set equal to 0, and then you would complete the square to find the numbers that go here, just so you could get it to be in that like standard form, which would be the x minus h squared plus y minus k squared equals 0. So I think Math Excel will accept this form, so we'll just go ahead and leave it like that. And on your test, you can leave it like that too, that's fine. All right, so the next one, so I have theta equals pi over 4. So this is a tricky one. Okay, so I didn't give you like an equation where if you had theta, you could replace theta with something. So I gave you 3 equations. I said x equals r cosine theta. I said y equals r sine theta. And I said r squared equals x squared plus y squared. So really, if you see the theta equals problems, what I want you to do is I want you to think about the graph. So we talked about graphing in section 27, part 1. So if you have theta equals pi over 4, that means that you have 0 comma pi over 4, 1 comma pi over 4, 2 comma pi over 4, and so on. And you're also going to have negative 1 comma pi over 4, and so on. Okay, so you're going to have all these points along one line. So if you think about what line that is in the xy coordinate plane, I think it makes a lot of sense. It's just the line y equals x. Okay, so that is the easiest way to switch forms if you just have theta equals a number. So I wanted to do one more, just in case, you know, if you had another one. So let's call this part G. So what if you had like theta equals pi over 6? Well, pi over 6, that means that you're going to be along this line right here, the pi over 6 line. And we know it goes through the point 0, 0 for the rectangular coordinates, but we don't know m. Okay, so we don't know the slope of the line, but we can figure it out. So if you think about how much it rises and runs, right? So let's say we have a point right here, out 1 unit, then it's really just a unit circle value. It's saying you go out root 3 over 2, up 1/2. Well, that means that's your slope, right? Your m is going to be the rise, which is 1/2, divided by root 3 over 2, which is 1 over root 3, which is root 3 over 3. So if we talk about y equals mx plus b, it's going to be y equals m x, and then b is 0. It goes through the origin, 0, 0. So that is the way that you would switch forms. So the question is, well, how do we get this root 3 over 3 thing? And what we did is we did the y value divided by the x value. So the slope is always the tangent of your theta, okay? So if you ever need m, you just are really just doing the tangent of theta. Okay, so this next one, so if I see r equals 2 sine of theta. So these are the trickiest ones for students. Because they know that if they had r squared, they would be good. They know that r squared is equal to x squared plus y squared, and so they really just try to square both sides, and they think that that's going to lead them in the right direction. So what they try is, like I said, they try to just square both sides. Okay, but then that gets them to 4 sine squared theta, and it really doesn't help at all, because you don't have r sine of theta. You can't replace it with y. So I don't want you to square both sides in this situation. I want you to think about another way that you can get r squared. So what you can do is you can multiply your equation on both sides by r. Okay, so that's what the trick that you need to kind of keep in your back pocket for these ones. You just need to multiply through by r. So you get r squared equals 2r sine of theta, because then you're almost done. So then r squared is equal to x squared plus y squared, and then 2r sine of theta is going to be 2 times y. So that's going to be your equation. And again, that's a circle, because I know I have 1x squared plus 1y squared, so I could get it in that standard form if I want. All right. So I want to briefly talk about conic sections and polar coordinates. And you don't need to memorize this whole box. I can give the box to you if I put this on the test, so don't memorize. Okay, there are a couple things that I want you to keep in mind. So the first thing is that if you have an equation that looks like this, it ends up being a polar coordinate. So it ends up being either hyperbola, an ellipse, or a parabola, or a circle, which is really kind of a form of ellipse, right? And the eccentricity is the E equals the absolute value of B over A. So if E is equal to 1, it ends up being a parabola. If E is greater than 1, it's a hyperbola, and if E is less than 1, it's going to be an ellipse. So like I said, I can give you this little chart if you need. The other thing to keep in mind is that one of the focus points is at the pole. So for a parabola, there's only going to be one focus, but for an ellipse and a hyperbola, there will be 2. And there's lots of other things that you can know about these graphs, but I'm not going to ask you a lot of terrible questions about them. It's really just going to be kind of on the graphing calculator test, and I'm going to have you notice a couple things. So the first one, so it says consider the polar equation r equals 8 over 3 plus 5 cosine theta. So I went ahead and I graphed this using my graphing calculator. So you guys can do that on yours if you want to. And what it looks like is a hyperbola. And it goes like this. Okay, so it's a little bit tricky, but we know that one of the focus points is at the pole, so it's at 0, 0. And then we need to find some other important points. Okay, so the question is, what is this point here and this point here? And you can try to kind of play around with it on your calculator, but it's hard to tell for sure what those points are. So what we're going to do is think about how many radians I'm out. Okay, so we know polar coordinates, so the way we graph them is by going out 0 degrees up, pi over 2. You know, you could go in all those different directions. So in this case, oops, sorry. In this case, this is probably going to be out 0 degrees, or it's going to be pi degrees. Okay, so I'm going to plug in. So plug in 0 and pi to find the vertices. Okay, so those are going to be important points that I will ask you to find. So maybe I will go ahead and graph this for you so you can see kind of a shortcut to putting this in. All right, so I'm going to put 8 over 3 plus 5 cosine theta. Okay, so I'm going to go to polar coordinates. I'm going to go to y equals, oops, let me make sure I was in radians. Yep, okay, so y equals, and I'm going to do 8 divided by 3, oops, sorry, divided by, oh goodness. Terrible at like typing this in on the calculator. Of course, it's got like a spinning ball now. Okay, so 8 divided by okay, sorry that took so long. Okay, so when you hit graph, you can kind of see that it's hyperbola. It goes ahead and graphs in those asymptotes though. And you could guess and you could think, oh, it looks kind of like 1, and then this is 2, 3, and 4. But you're not totally sure, because maybe it was like 1.1. Like, how do you know? Okay, so what we're going to do is we're going to go to second table, and we're going to put in some different values. So you guys have already changed yours, so you can put in whatever values you want. So I'm going to go to independent ask, like we did the other day. So I can put in whatever values. So I want to put in 0. So I get the point 0, comma, well, r comma theta, so 1 comma 0. And then I want to put in pi. So when I do that, I get pi comma negative 4, and I get 0 comma 1. Guess I called it the wrong thing. Go here. So I don't want to say 0 comma 1. I want to say 1 comma 0 and pi comma negative 4. So let's think about in polar coordinates what that means. It means along the 0 line, I'm going to go out a unit 1. Along the pi line, which is out here, I'm going to go backwards, negative 4. So 2, 3, 4. Okay, so those are the 2 points that I have. So I will definitely ask for vertices because those are important, so know how to find those points. Okay, and then we know the distance to the focus is only 1 unit, so this distance is also going to be 1 unit. So it says, show algebraically that the graph is a hyperbola by transforming into rectangular form. Okay, so this is a little bit tricky. So if I'm switching to rectangular form, what I'm going to do is I'm going to multiply my denominator over first. So I get 3 r plus 5r cosine theta equals 8. And I know that r is equal to the square root of x squared plus y squared. R cosine theta is going to be x, and then I have my 8. And I need to adjust this. So I'm going to subtract my 5x over, and I can divide by the 3, or I could leave it on that same side. It doesn't matter. But I'm going to square both sides. So when I do that, I get x squared plus y squared equals, and then I FOIL at the top, so 64 minus 40 times 40, or 40 plus 40, so 80x plus 25x squared all over 3. And I multiply over. I should have given you much more room for this. I didn't really think about, oh yeah, this will take a lot of steps. All right, so I'm going to have 64 minus 80x plus 25x squared. So when I subtract over, really all I want to see is that you have like either an x squared minus y squared or a y squared minus x squared. So when you subtract the 25 over, you do see that you get negative 22x squared plus 3y squared equals 64 minus 80x. And that's enough to say that it is a hyperbola. Okay, now really, you know, I could go back to kind of like what we did with algebra 2, and I could get it in the form where you have like x minus h squared over a number, blah, blah, blah. But I'm not going to ask you to do that. I really just want you to see that it's like an x squared minus y squared or a y squared minus x squared, therefore it's a hyperbola. It's a little bit tricky. Like, I know you guys are probably thinking, oh, but if I have a y squared minus x squared, then that should be a vertical ellipse, right? Or a vertical hyperbola. And there's some more going on with this because it was a negative 80x. So you could get it all on one side and you'll end up dividing through by a negative number, which switches it. So I'm not going to do all of those steps, but yes, it's definitely a hyperbola. And then one focus of the hyperbola is always at 0, 0, right? If you wanted to find the other one, like I said, we would add 1. So it's going to be at negative 5 comma pi would be the way that I would write it. Kind of like the negative 4 comma pi. And then the eccentricity is always the b over a. Which in our case is 5 divided by 3. And we leave it like that. So that's another way to verify that it's a hyperbola, because we saw in the little box that if e is greater than 1, then it's a hyperbola. So that could be another way that you verify that it is a hyperbola. So I may not ask you to do part B. I might just say, you know, find the eccentricity and tell me which kind it is. All right, so the next one. So when I graphed this one, I ended up getting an ellipse. And it was kind of hard to see. You could always adjust your window if you need to. So the highest point was at 2 and the lowest point was at 10. Okay, and I went ahead and I plugged in pi over 2 and 3 pi over 2 using my calculator, because I knew that I was along the pi over 2 line and the 3 pi over 2 line. So when you plug in pi over 2, I guess maybe I didn't write down what I got, but I think you get 2, right? So if you do sine of pi over 2, sine of pi over 2 is 1, 3 plus 2 is 5, 10 over 5 is 2. And then if you plug in 3 pi over 2, right, that's giving you negative 10. Because you'd have 10 over 3 minus 2. So you would get, oh, I guess you get negative, yeah, that's right, positive 10. Almost got a bonus point there. Okay, so you would get positive 10 because you're going in that direction, right? All right, so there's your kind of rough sketch. Again, you know that one focus is always at the pole, so the other one is going to have to be at 8. So you're going to have 0, 0, and then you're going to have 8 comma 3 pi over 2. You could also write it as pi over 2 here and then negative 8 if you wanted to. All right, so we want to show that this is an ellipse by transforming into rectangular form. So again, we're going to multiply the denominator over. So I'm going to have 3 plus 2 sine of theta times my r equals 10. So I'm going to get 3r plus 2r sine of theta equals 10. So 3 square root of x squared plus y squared plus 2y equals 10. So 10 minus 2y equals 3 times the square root of x squared plus y squared. So I said you didn't have to divide the 3 over. You could just square. So make sure you square both things. So you get 9 times x squared plus y squared equals 100 minus 40y plus 4y squared. Oops, plus 9y squared. And continue to solve. So really the big thing is that I want to see I have my x squared added to my y squared term. And if you subtract over, you do. You get 9x squared plus 5y squared. And then you can leave the 100 minus 40y over here. So again, there are things you can do to get this in the standard form that was more familiar when we were in Algebra 2, right? So you could, so I would leave it like this for the test, but you could add the 40y over. So that way you can complete the square, right? So really, the way that you would write this is we would add 16. We take the 8 divided by 2 squared, which is really adding 80. So we would add an 80 on this side. So when we do that, we get 9x squared plus 5 times y plus 4 squared equals 90. And we would divide everything through by 90 to get it set equal to 1. So your final form would be x squared over 10 plus y plus 4 squared over 18 equals 1. So then you could tell exactly how much it's moving up and down from the center and so on. Okay, and then the last thing, see what is one focus of the ellipse. We just gave both of them, and the eccentricity is b over a. So our b value was 2, our a value was 3. So we're going to get 2/3, which we said is less than 1, right? So when we have e is less than 1, we do have an ellipse. All right, and then the very last one is going to end up being a parabola. So we'll have an eccentricity of 1. So if you sketch a rough graph, so on your calculator, if you put this in, you end up getting a parabola that's opening to the left. And if you weren't sure what this point is, then you plug in 0, because it's along that angle of 0 degrees, or 0 radians, I guess. So you get 6 over 1 plus cosine of 0 is 1. So we get 3. And it does look like 3 on your graph, so you would definitely have that. So I'm going to write it as r comma theta, so 3 comma 0. We know this point is at 0, 0. That is the only focus. Like I said, the eccentricity is b over a, but both b and a are both 1. So we get 1, which means that it's a parabola. And then if we wanted to switch forms, we would multiply the denominator over. So I'd get r times 1 plus cosine theta equals 6. So I have r plus r cosine theta equals 6. So square root of x squared plus y squared equals, plus x equals 6. So 6 minus x, and then square both sides. So x squared plus y squared equals 6 minus x. So x squared plus y squared equals 36 minus 12x plus x squared. So you can see what happens is the x squared terms end up going away. So you get y squared equals 36 minus 12x. And I would accept that on the test. If you wanted to see what it was in Algebra 2, remember, it was always, I always said there was a little bit of flare on one side, and then there was a little bit of flare on the other side. So this is one where you had the y squared. So that meant the 4p went with the x. So if you were trying to get it in that form, we already have like the y minus 0 squared. And then if you pull out the 12, actually a negative 12, you would get x minus 3, like that. So your p ends up being 3, or negative 3 really. So that's why it's opening to the left. And then your vertex is 3 comma 0, which it definitely is. So you can see you can always get it to be in those standard forms that you learned in Algebra 2, but it's a little bit of work to do it. So I'm fine if you leave it like that. However, I don't know how Math Excel is. So if Math Excel makes you do that, then go ahead and do this other step. You all know how to do that, and you can get it in that form. So that's the end of section 27. So sorry, it was a little bit long. That's why I decided to break it into 2 pieces. So hopefully you can do the homework problems and come to math help if you get stuck. All right. Where are my little